Friends, so like in last lecture we have seen types of medicines, how we are going to classify our medicines. Okay, so today we will learn about target of medicine, how our medicine will work. Okay, so very important chapter, and this topic is very important. Please keep your notes with you and just note down some important points. Refer textbook and refer this video twice, and please use your headphone if is it possible. Okay, so now let's see. So till date we have seen the classification of medicine. The next point is target of medicine. So we are knowing that in our body there are lots of biomolecules. I can say you can see like this. Protein is there, then carbohydrates. Okay, carbohydrates will provide energy to us. After that, a lipid portion is there. Okay, to control our genetics, I can say there is DNA and RNA portions are there. Nucleic acid, I can say. Okay, that one is the basic portion of genetics. So now, come to the point. Today in this chapter, we will learn about the protein. Okay, and how your drug molecule will bind to that protein portion. Okay, so in our body, basically you can see proteins are of basically three types. One, they will act as an enzyme. In the second portion, they will act as a receptor, and the third one, they will act as a carrier protein. Okay, so in this chapter we will cover 2 points, mainly enzyme and receptor, how they are work. Okay, so let's start. Okay, with the enzymes. So basically proteins are two types. Okay, in this chapter we will cover two types of protein. One is enzyme and another one is receptor. They both are good target for our medicine. They both are very good target, okay, for our medicine. So one by one we will see. Now come to the point, enzyme. So first of all, we should have some idea about enzyme. What do you mean by enzyme? As you can see here, enzymes are the proteins which will increase our biochemical reaction, okay, in our body. Each and every cell needs biochemical reactions to do nicely, okay, or to do good work, okay, and due to that all biochemical reactions, our living system will work nicely. So if there is any kind of interruption or agar wahan pe theek thak karna hota hai, so in the same way, what I can say, enzymes are the molecules which will control the rate of biochemical reactions. So enzyme will basically increase the rate of reaction and they will control the biochemical reaction. And enzymes are very specific. जो enzymes होते हैं वो बहुत ही specific होते हैं. जो enzymes है वो किसी particular I can say substrate के साथ ही जुड़ सकते हैं. Suppose I have one enzyme, that one is like sucrase, or I can say invertase. So invertase enzyme will bind with sucrose only. That invertase enzymes cannot metabolize any other substrate. Okay, so why is it so? Why enzymes are specific? So as we are knowing that enzymes have a specific site, that one is called active site. Look at that. That one is active site. Okay, in this diagram we can say that hexagonal and pentagonal is substrate. Okay, that one is an enzyme, and enzyme has some functions as an active site where your substrate will bind. Okay, you can see that. So once that substrate will come to the enzymes, when your substrate will come to the active site, your enzyme will bind with that substrate with the help of hydrogen bond, van der Waals bond, okay, and a dipole-dipole interaction. Okay, after that, what I can say, that intermediate will convert into the product and we will get our enzymes like in same situation. where it was first. Okay, वो जैसे पहले था एंजाइम्स वैसे लास्ट में हमें वापस मिलेगा. बोलना ये चाहता था कि एंजाइम स्पेसिफिक है, वो एंजाइम सब्सट्रेट के साथ जुड़ते हैं, कॉम्प्लेक्स बनाते हैं और प्रोडक्ट हमें मिलती है. और आफ्टर दैट रिएक्शन, आफ्टर द कंप्लीशन ऑफ दैट रिएक्शन, हमें जो है वो एंजाइम उसी स्वरूप में वापस मिलता है जो पहले था. ओके, तो बात ये बनती है कि एंजाइम जो होते हैं वो एक से ज्यादा बहुत सारे मोलिक्यूल्स को क्या करते हैं, प्रोडक्ट्स में कन्वर्ट करते हैं. ओके, सो दैट इज द एंजाइम. ओके, सो नाउ व्हाट हैपन, many times we will use drug which will control our enzyme, and many times mostly that drug will block the enzyme activity. जो औषध है और हम कह सकते हैं जो दवाइयाँ है वो क्या होती है, मेडिसिन, वो पर्टिकुलर एंजाइम्स को डीएक्टिवेट करते हैं. सो किस तरह से डीएक्टिवेट करते हैं वो हम देखने वाले हैं. बाय आई कैन से देयर आर टू वेज through which our medicine will block that enzyme, and I can say you that in this picture we can say, listen, that first look at the top one. What happened here, we are adding some medicine, or I can say some molecules which are similar to that our substrate. So enzyme will be confused between substrate and medicine. If our medicine will bind to that active site instead of that substrate, so now your enzyme will not able to convert that substrate into product because medicine has taken the site of enzyme. So that medicine will block the action of enzyme. I think, are you getting this point? If you are not getting, please to pause this video and just revise it. Once again, let me revise it very fast. There is an enzyme having an active site. It will convert substrate into product. But what we are doing, we will add some medicine which will compete with that substrate, and that medicine will bind with that enzyme. So now that enzyme cannot convert that substrate into the product. So we are going to block the activity of enzyme. Okay, in a simple way. So I can say that one is a competitive inhibitors. What I can say, they're all the medicine which will bind with the enzymes to restrict the reaction. I can say that medicine which is similar to that drug, that substrate, is known as competitive inhibitors of enzyme. So this one is the one mechanism through which we can control the action of enzyme. Now come to the point, that second one, on enzyme there is one allosteric site. Okay, you can see on enzyme there is one allosteric site. Okay, that one is different than active site. In your enzyme there is one active site, and another one is, that one is allosteric site. You can see in that picture. So when you are going to add some drug molecules, so that drug molecules will not bind with the active site. That drug molecule will bind with the allosteric site, and by making bond formation with that allosteric site, when your drug will combine with that allosteric site, the active site will be changed. That position and the shape of that active site will change. Now substrate is there to bind with the enzyme, but active site position and shape has been changed by the drug molecule, so your substrate cannot bind with the enzyme, and that's why your medicine will restrict the action and mechanism of that enzyme. So you can control the reaction of enzyme. You have blocked the enzyme. So in many cases, to get good biological response or good biochemical reactions, we will have to block our enzymes, and that's why we can cure disease, and we can be ready to fight with that disease. Okay, so now there is one drawback. Your drug molecule, if your drug molecule will bind with the enzymes with the help of covalent bond. So that complex now cannot separate drug molecules from the active site because that drug is bound with the help of covalent bond. So ultimately, our body will degrade that complex drug plus enzyme complex, that our body will degrade that complex and will be regenerated again, and our protein will be generated and will act as an enzyme once again. So slowly we will recover from the disease. Okay, so this one was entire phenomenon about drug enzyme interaction. Okay, how your drug will attach to enzyme to have a good biochemical reactions and to make preserve our biochemical reaction. Okay, thank you very much.